Okay, so this is part two, climate data analysis, the factors that influence climate. The factors are latitude and your average exposure to specific air masses, your elevation changes more than a few hundred feet, position relative to the mountains, whether you're on the windward side or the leeward side. One side will be drier and the other side will be moister. Proximity or nearness to large bodies of water, that would be large lakes like the Great Lakes or oceans. Proximity to different ocean currents. And a simple example would be off the coast of the east coast of the United States, we have a famous current called the Gulf Stream, which comes from down near the Gulf of Mexico and is warmer, and it influences our climate, keeping us milder and wetter. Whereas California current on the west coast comes from the north and brings colder air and therefore drier conditions to the west coast. Climate elements, things that we can measure and evaluate: average temperature and temperature variation, average air moisture content, and average precipitation amounts and the variation over the course of a year. So in this area here, this is mostly things to think about and to help you use the chart. Down here you'll see there's this chart or climate data where we have in column 1 we have links to some weather maps or to some location maps and some data about the climates for two cities. Here we have the two cities. Cities 1 is in Colorado is going to be Vail, Colorado, and column 2, Denver, Colorado. And then in column 4, this is where you're going to list the factors that you think are influencing the climate here. And then in the final column on the right here with the purple heading, this is where you put the factor that you think makes the biggest difference. Okay, and so let's go take a look at this table. If we click on this link, it's going to bring you to this table. You start out here with this map. This is for Denver. Denver's over here, and Vail is over here. And remember, Denver is called the Mile High City because of its high elevation, but Vail is even higher. Let's see how much higher on the table below. And let's also notice that Denver and Vail have almost exactly the same latitude. And that tells you something. That tells you that latitude will not be a factor because they both have the same latitude. So let's look at the data table for them. And you can see that Denver is at a lower elevation, but it's still at 5,286 feet. So that's almost exactly a mile above sea level. And then over here you have Vail, and Vail's at 8,690 feet. And that's much higher. And that's probably going to play a difference. Okay, there's a reason that Vail is up in the mountain, or why the ski resort is at Vail up in the mountains. All right, so look at this. The annual temperature. Looking at the annual temperature for Denver, that's like the average for the whole year, 50 degrees. Whereas the average annual temperature for Vail, Colorado is only 37. It means you're going to be spending most of your year below freezing. So in January, the high temperature could be 16, or the average temperature could be 16. February, it's 20. In March, 28. I mean, it stays cold a long time. Even in the middle of summer, the high temperature is only 59 degrees in July. Okay, so it makes a great place for a ski resort. But let's take a look then at our table, and let's fill in the data in our lab. So for this one, what are the factors that could contribute to this difference in climate between these two? And the answer is elevation. Now specifically, what do you mean by that? In column 5 here, here's where you explain that difference, and you're going to have to write a little bit. So here you would say something like Vail is at a higher elevation, resulting in lower annual temperatures. Okay, and then I'll let you figure out what you would say for Denver. Okay, but you get the idea. You give a little more explanation here after you've identified which factor is most significant. Okay, so that's your intro to part 2.